Thanks, Betsy. So my name is Ramon Guiu. I'm Director of Product Management for Infrastructure. I work from the growing Barcelona office. We're 30 engineers, product managers, and designers now. And there we build the integrations for infrastructure as well as the new Relic UI platform. If you like sunny weather all year long, tapas and wine, and you would consider moving to Barcelona, the office is growing, so can check for opportunities. So the legal department says we have to show this. I may be making some forward-looking statements, and I don't want to be held accountable for those. Anyway, it's just something we have to do. In the hundreds of conversations that we've had with customers, there is a recurrent topic. There is that comes over and over again, and that is the need to monitor a wide variety of infrastructure components. And some of them are actually pre-custom, right? So this is, if that is something that you care about, you're in the right session, because we're going to be talking about how New Relic infrastructure and the integrations SDK will allow you to monitor absolutely anything you want. But before we start, can you raise your hand if you have heard about the infrastructure SDK before? OK. Will you keep your hand up if you have actually tried to use it? OK, we have yes, a couple of people. OK, it's cool. All right, so I'm going to go through some slides first to explain what the integrations SDK is and how it works. And then I'll jump into a demonstration where we're going to be looking at a few examples of integrations. We'll be looking at the code and how the data is reported to New Relic. But before I get into that, I want to start by defining, for those that may not be sure what an infrastructure integration is, it's just something very simple. It's a piece of software that collects, captures monitoring data, and sends it to New Relic servers. And we have, at New Relic, we have two very different types of infrastructure integrations. We have on-host integrations, and those are integrations that are used to monitor, collect data from components, infrastructure components that you manage. The way to capture the data is very different, varies from component to component. We use a specific method, maybe an API, maybe a command line tool, maybe we parse the logs to get some of the data. And those integrations run on your infrastructure alongside the infrastructure agent. Cloud integrations on the other side are integrations that capture monitoring data for cloud services like Azure or AWS. And to collect the data, we use publicly available APIs. And because they are available, we can actually run all those integrations on our servers, which makes it probably easier for you because you just need to do some configuration steps, and we can go ahead and capture the data. Something also important to keep in mind is when we talk about monitoring data, we're talking about three things. We're talking about metrics. So this is health and performance. This helps you understand the health and performance of your infrastructure. We're talking about operational events. Those are things happening in your infrastructure at a specific time, like a service is restarted, somebody has logged in, a configuration parameter was changed. And then we have something very specific that sets us apart from other monitoring tools, which is inventory. And inventory is live state data about your infrastructure. This is the configuration of the components, where are the packages that you're using on your operating system, where are the versions. So we capture all that, and we monitor changes and drifts over time. And also how, across your infrastructure, you may have different things installed. So where does the SDK fit in this picture? The integrations SDK allows you to build on-host integrations. And it provides so publicly available, the SDK that is publicly available today allows you to use integrations in sort of a pull mode. And I'll get into the details of that, but basically you can use any programming language to code to develop those. We have specific tools for Go that we will also be looking at, a set of libraries to make the process a lot easier. There is a JMX component if you need to connect to a JMX service like Tomcat or Kafka to capture the metrics. there is also a command line tool that allows you to bootstrap the creation of an integration very quickly. You run it, and it already creates an scaffold for you. Again, we'll be taking a look at that. But here at Feature Stack, we're announcing something new, which is push mode, which is available in private beta. If you want to join, talk to your account executive, and we'll see. You meet the criteria, we'll help you join it. And what it does is it exposes a local endpoint. The agent exposes a local endpoint where you can push information. And again, you can use any programming language to push the data. And the other thing we're adding is a statsd backend. So if you're using a statsd and you're pushing your metrics to your statsd, you can add that the new Relic backend to statsd, and the data will be pushed to the infrastructure agent, and in the end will end up in our servers. On top of that, as of course, with all the data that we capture, you can use the platform capabilities like dashboards, building custom dashboards and alerts. So let's take a look at the pull mode. So pull mode, the way it works, it's you create a custom integration. That custom integration is basically 3 files in its more basic form. There is an executable, which could be a bash script, or it can be a binary, or wherever you want that the OS can execute. There is a definition file and a config file. And once you enable it, the infrastructure agent will run it at a defined interval. And the integration, the only thing it needs to do is go. When it runs, it goes, captures data from the infrastructure component, and prints metrics, events, and inventory, whatever you capture. It prints it in a JSON format to std out. And the infrastructure agent will take that data and send it back to the Relic servers. So again, this is very cool because actually you can test your integration without having the agent or any setup. You just run it on the command line, and you can see if it's outputting what you want. The second mode, which is what we are introducing here at Feature Stack, is push mode. And the way it works is that the infrastructure agent is listening to a port, basically, and you can push data in the same JSON format that a pull mode integration will use to send data to New Relic. When you're sending data, actually you could think there are 2 ways that you could use it. You could actually send data to a statsd and then use the backend to get the data, the aggregated metrics, into New Relic. The thing is that it's limited by the data that statsd support, which is basically metrics. You cannot send events or inventory, or you can actually be pushing the data yourself, and in that case, you can use the wide array of data types that we support. We'll see an example later, but just for you to get an idea, this is how the JSON message looks like. There is a header with some metadata, and then there are 3 sections, 1 for metrics, 1 for events, and another 1 for inventory. And we'll see what the data inside those sections look like. So with no further ado, let's jump into demo time. OK, so let me see. This is running. Cool. So this is a bash integration. And this bash integration, you'll see, has the 3 basic files. So there is the definition file, a config file, and this is the binary file. So let's look at the definition file. The definition file just has some metadata here. OK, what's the name? It has to be unique. That's how the agent knows, OK, this is this integration. It uses the name to identify the integration. Protocol version today, just 1. In the future, if we add new features, we may increase the number, and that will help us ensure backwards compatibility with integrations that use a previous version. Some description that is for you to know what the integration is doing. And then OS, you can use Linux, Windows, or both. And what it does, it tells the agent if this integration can run in that operating system. So if we try to run this integration on Windows, or we configured it, the agent would actually ignore it because it's not designed to work on Windows, because it's only for Linux. And then here you have a command section. So an integration, I have a set of commands. Those are basically the executables that your integration provides that will go and capture data. And for each of those commands, you have what the executable is, the interval. This is at what frequency it will be executed by the agent. And then this prefix thing, don't pay too much attention to it. That is for inventory, how it gets classified inside New Relic. We'll take a look at it later. So then when we get into the config file, in the config file, you can define multiple instances for the integration. That means that is multiple executions, different executions, independent executions for that integration. So in that case, this integration is collecting directory file count and total file size or space in this that the directory consumes. And we have two instances because we are running it once for the TMP folder, and we will be running it another time for var log. So basically, the agent will read this and say, OK, there are two instances. I'm going to schedule 2 instances of this integration to run every 30 seconds, and I'll pass these arguments to those instances. And so now let's take a look at what the shell file is doing. So it is very simple bash script. Here I'm doing some checkings to make sure that the dir name is specified. So you'll notice that this is checking environment variables. So all the arguments that you see here are set as environment variables before the agent runs the integration. So that's how the integration can get access to the arguments. So we have dir name here. And basically, we just have, this is executing 2 commands. This one to capture the file count, and this one, this usage to capture how much this space this specific integration is using. Then it will generate an event if the size of the folder goes over max size, which again is another argument here. So this is a threshold. It's going to say, so if this directory is occupying more than this amount of bytes on disk, generate this event, and that will be sent to New Relic, and you will be able to see there. And then it's capturing some inventory data. So inventory, as I said, live state, things like version, metadata about your the system. So in this case, it's just sending metadata about the integration itself. So for example, you could use this to see if you're running the integration on 1,000 hosts. You could actually see if you're running different versions of that integration across your across your infrastructure. Then here, the integration, the way it works, because in Bash you don't have a native way to create a JSON message. There is a JSON template, and here in the code is just doing some string replacement to add the data into the right place. So once you have your integration, you have to, you upload it to the host. You configure the agent to run it, which is basically putting this configuration file in a specific folder, and then magic will start happening. So this is a dashboard I have built inside Insights that is showing data coming from that particular integration. So if we look here, you'll see, in the template, you'll see that data, so the way we capture metrics is we're generating samples. And a sample has a set of key value pairs. And in there you have, some of these things are metadata, but most of the thing will be metrics that you're capturing. And it's being stored, this is the place, this is where you're telling New Relic, OK, store these samples inside, if you want, this table in our system. And so here in Insights, if we check this query, for example, we can see we're running this query where we're getting, OS file count from this, this event. We call it event, but this table, which is my order size sample, which is the name that we gave it. And we faceted by dir name. I don't know if it's visible, but actually you have temp, which is very very slow, very small folder, and is log. It has a bunch of files. Then we just have one. And here in size again, it is like almost 50 meg. And temp is very small. So this is where metrics are going and how you will build your custom dashboards here. Here, these are events. And what we can see here, so if I click in here, I can see that this is generating one event every time it runs. It's generating an event for both TMP and var log size, because both are above the thresholds that I said, which are different. Okay, for TMP, I said like 20,000. And for var log, I said, I believe it's 1 million, right? And so 50 million is above. So it's generating events, and the data for events is available here. And finally, we can check, this is the data for inventory. So this is the prefix, this is the prefix that we set that I mentioned before that we set in here in the definition file, integration my.org.info is showing here. And inside, we can see data about the data that we actually send, which is we set the integration info, and we set an author, a name, and a version. And here we just see one host, because I'm only running one host. If I have 3 hosts and maybe version is different, actually here I'll see that there are maybe two variants of that integration running across my infrastructure. And then finally, we have alerts. Okay, so if you go into our infrastructure alerts, inside integrations, you can then select the sample where you're storing the data, and you can set alerts on the 2 metrics that we're capturing. And you have here a graphic to help you actually define the threshold correctly. So that is you can use any programming language. Very simple example using Bash. Now let's take a look at something slightly more sophisticated, which is using our Go libraries. So what we can do here, so this is Enter Integrations Builder, is the command line tool that helps you create an integration. You need to pass it, you call it init with a couple of parameters, and then the name of your integration. And when you do that, the tool is going to grab a bunch of different libraries, the SDK and some other libraries, to create the scaffold. It's going to generate a bunch of files. And so if we now look at the folder that has been created, we can see that, so let me close this. So we can see this is the config file. It creates a sample. So generally, when you package your integration, you don't want to include a config file, a config YAML file, because you may be overwriting the existing file. So you probably create a sample, and then in that particular machine, you'll create the specific configuration for that machine. So if you want to deploy again your integration, you're overwriting the sample, but not the configuration parameters that were set specific for that machine. You have the definition YAML file. Again, similar structure, but it's filled in automatically based on the data that you provided. And then this is the source code for your binary, your executable, which is in Go. And it does all the heavy lifting. It provides already automatically a bunch of arguments that like pretty printing the JSON, so you can see it more nicely instead of in a one line, which is what gets sent to the agent. You can set verbose mode. There is a logger. It generates the JSON for you automatically. So basically, the only thing you have to do is you have to come into those 2 functions, populate inventory, and populate metrics, and call the functions that you see here. Set metric to add a metric, and here is set item in the case of inventory to add an item to inventory. So now let's look to a specific example that is using the Go SDK. So this is the source code. It's the same thing. It's not different. The main change is that we've added a couple of parameters, hostname and port. This is an integration to connect to Redis and capture a couple of metrics. And then in populate metrics, what we're doing is we're calling this command, Redis CLI info, and doing a grep on this value. So you actually, if you do a Redis CLI info here, it gives you a bunch of different metrics for your instance. And if you do grep, then you will only get that one. So this is, by the way, if you're capturing all the metrics, this is not the most efficient way to do this, but for the purpose of this example, this is a quick way to do it. So we're getting instantaneous operations per second. We're parsing the string that we're getting, and here we're adding it as a metric. Something important is this, metric gauge. So when it is, we have 3 types. So you can use a gauge if the only thing you want is the exact number that you're providing. You can use rate if you want us to compute the rate of change. And what is happening is that we will be caching the previous value that was sent. And once we capture the next value, we compute the rate of change. So for example, in MySQL, the number of queries is a counter that is increasing all the time. So this is helpful to actually see how many queries per second your MySQL instance is getting without you having to do any computation. You just set capture the value and set here metric rate. And then we also have delta, which is just the difference. It won't calculate the rate. It won't divide by the change in time. It will just give you the difference between two samples. Here is doing exactly the same thing, but for a different metric. And then in inventory, is using the same command, rediscli config, and getting, is doing get bind, which gives you, this configuration parameter, and here db file name, and it adds it using inventory set item. It's adding it into the inventory structure. And then that's all we did. All this code is standard. We didn't change anything. It's automatically generated. And so the SDK is going to take the data that you provided, build the JSON structure, and publish it to std out for the New Relic infrastructure agent to consume it. And so again, if we go here, we'll see the same thing. So we can go into Redis, and we actually see, well, here there is no data. So let me generate some data, actually. So there is a tool called Redis Benchmark that can generate, a bunch of generates a bunch of requests. So you can do tests, and we will see in a second data flowing in here. We're not generating any events, so we won't see this. But we are capturing the data. The two configuration parameters that we're capturing are showing here. And again, this is actually pretty important. So imagine that you have MySQL installed across 15 nodes, and parameters like what's the pool size. You can actually check if you have different values across your infrastructure. An example, if you're thinking more in terms of security, SSL library. So if you're running an SSL library that has a vulnerability, you can actually come into inventory and see, oh, okay, so I'm running, these are the versions that I'm running, and this is the actual host that is running a version that has a vulnerability, so I can go in and fix it. So you see now that data is coming in. Okay, and the last thing I wanted to show is the statsd integration. So let me come in here. So as I said, we've built a backend for statsd. And so for you, even if you're not familiar, so basically here, this is the statsd configuration file. Here you list the backends that you wanna enable. Basically a statsd backend, so statsd, the only thing it does, it receives metric and then it aggregates them, and at the specified period, it generates like, okay, the average, the sum, the count, etc. for each of those metrics. And then you can enable a different set of backends to send the data somewhere, to do something with that data. So in here, we have only enabled the New Relic infrastructure backend. And the thing that is important is this section here. So this is how you configure the backend. This is the port where the New Relic agent is listening for data. This is the host, so we're actually sending the data, just in the local host because the infrastructure agent is running there. And what we do then, we run some regular expressions. So a metric in a statsd metric usually looks something like this. So it's a bunch of dot separated strings, and using this configuration, you can actually parse those strings and generate some metadata that is useful for then filtering the data in insights when you're building dashboards. So match expression. So we're going to be captured. So I've installed Redis. What I'm going to be doing is I downloaded a tool from the internet that what it does is goes connect to Redis, more or less like we did, and it sends the data using, it sends the data to statsd. That's what it does, okay? And so if we look at this, if we look quickly at this tool, so I'm gonna start statsd. So it runs. So this is the tool, Redis statsd. You can tell it how often to run it, so it will run every 15 seconds. And then you set a prefix for all the metrics that it captures. So I set Redis prod. Let's say this is a prod instance, and I use Redis so I can then understand that the metrics I'm getting come from Redis. So I execute it. Let me put it in the background. And if we look at the logs, we can actually see, so what you see here is I have debugging traces enabled. So what our backend is doing is parsing all the metrics that it receives and checking. So it says, OK, statsd bad line. So this is some metrics that the statsd generates automatically. But here, you start seeing the Redis metrics. So Redis, prod, this is the prefix that we specified for that tool. Total connections received per second. And so when we get this string, so we put it here. So we're getting something like this. So what we're doing here, OK, this is going to match Redis. This is going to match this because this is the regular expression to filter the metric name that we're getting. Then this is the metric schema. This we define some variables that we're going to use later. This is one is particularly important. Metric name is the name of the metric as it will appear in your Relic. And then app and environment are things that I've defined, and they are mapping to Redis and prod. Okay, so app, I have it here. So I define here a unique identifier for this Redis instance I'm monitoring. The event type that we saw before, this is where the samples will be stored. Again, you can use any name. This is the name that I picked. And then we can set labels that you can use then to filter the data. It's like tags that you set on the metrics. So you can then filter them in the UI. And one is hard-coded cache, but the other one I'm using environment, which is part of the statsd metric that is being generating. And in this case, it would be prod. So if I now go back to New Relic, I have a dashboard that I've built here. And so we see that there is, again, some data that I'm capturing through statsd. This is the query. So I'm looking at this event, the statsd sample, and here is user memory. In Insight, you have Data Explorer, will help you see all the data that is being captured. And here, so you can see these are all the metrics, blocked clients, connected clients, evicted keys, key space misses. These are all the metrics that are being captured by the tool that I'm using. It's sending to a statsd, and then our backend is just forwarding the data to New Relic. So if you want more information, statsd is in beta, so you won't see the information in the public documentation, but you have information about the SDK and the integration that we built. Everything is source available in GitHub, so you can go see our Go Sdk. Our own integrations are there, so you can go browse them. The NR Builder tool that I show is also a source available. You can go and see it. And these are the integrations that we have today available. Nginx, MySQL, and Cassandra are generally available. And then Redis and Apache are currently in beta. And if you want to play with it, you can sign up for a free trial, a 30-day free trial, and you'll get access to all this very nice stuff. Thank you. So you have any